Okay, let's make a start. We've got, looks like lots of people from around the world in all sorts of different time zones. So thank you for joining us. Good morning, good afternoon, and good evening, and good middle of the night if you're that keen. Very, very much appreciate you taking the time to join us. This is the first ever Groundhog geological software webinar that we've ever run. It's going to take the form of a live demonstration of the software. So we're not going to show you a load of boring slides. We're actually going to try and do something in real time. So I should probably caveat that by saying we've never done this before. Groundhog is not perfect software. So if we get stuck at some point, please bear with us. So let's just start by saying, what is Groundhog? Some of you on the call may have used it before, may be familiar with it or not. Some of you may have just seen this webinar pop up on our social media channels or wherever and just thought that might be interesting, so you may not know what it is. So it's geological software built by a team at the British Geological Survey. And the team, the sort of core team you'll see have joined us all today. So I think if we just take 10 seconds each, we'll go around the room and introduce ourselves. So perhaps Steve can go first.
Yeah, so I'm Steve Thorpe. I've been at the BGS for about 15 years. I'm part of the Groundhog testing community, I guess. So not the kind of software coding or anything like that, but the actual geological modeling and the testing of the software.
Okay, thanks, Steve. Maybe Tanya can go next.
Yeah, hello. I've been at BGS, I think more than 8 years now, and I've been doing software development on Groundhog since it was just a twinkle in our eye, so right from the very beginning, and I enjoy doing it very much, so I'm looking forward to hearing your views.
Thanks, Tanya. Let's go for Jonathan.
I'm working at BGS for about 2 years. Came in as an apprentice and now I'm a full-time employee, but looking more at the web side of things as opposed to the desktop software.
Thanks, Jonathan. Maybe Hannah?
Hello, my name's Hannah and I'm a geoscientist and spatial data specialist at BGS. Been at BGS about 14, 15 years, probably about the same as Steve. And my position in this team is similar to Steve's in that a bit of a guinea pig. I'm essentially trying to break this software so that the developers can fix it, but it's very hard because it's very good.
Thanks, Hannah, for your vote of confidence. Let's go for Tom.
Yeah, hi, I'm Tom Fletcher. I've been working at BGS and on Groundhog for 2 years now, and my kind of baby within the software is I'm a software developer, and I work on the 3D component, which I've built up from scratch since I've been here.
Thanks, Tom. And finally, Kath.
Hi folks, I'm Kath and I'm the resident geologist on the Groundhog team. I use Groundhog virtually daily in a whole bunch of different projects, including commercial work, usually helping to manage water resources. Back to you, Ben.
Thanks, Kath. Yeah, I should probably introduce myself as well. That would be good, wouldn't it? So my name's Ben Wood, and I lead the team that you can see here and working on Groundhog software development. I'm a software developer myself, and I've been at British Geological Survey for 20 years, pretty much almost to the day, actually. So what we'll do is we're going to switch to screen sharing mode in a moment, and I'll start the live demo. As we go through, please use the sort of Q&A functions to type in questions. The panelists will pick those up. If they're quick, easy ones, they might send you a response straight away. If they're particularly interesting ones, we might save those up to the end. I'm going to aim to speak for about sort of 40 minutes or so that we can leave a bit of time for questions at the end if people want to hang around. So let's go into screen sharing mode and make a start. So what will you see today? Well, I'm just going to show you the basic functions of the Groundhog geological software. Now, Groundhog is currently only available on Windows, so it's standalone Windows-based software, and it's available in 2 versions at the moment. Those versions are Groundhog Community, which is free to use for anyone in the world for any purpose, including commercially. And that's the version I'm going to demonstrate today. So everything you see today, you can do for no cost. You can just download that from the BGS website. We'll show you a link to that at the end. And that has the basic functions for things like boreholes, maps, and geological cross-section drawing. But there is a second version, which is our commercial version called Groundhog Professional. And that version adds tools for model building and editing, by which we mean both conceptual site models. So we have some tools specifically for the kind of geo-environmental / contaminated land sector, but also perhaps of sort of wider appeal, we're starting to put in some 3D geological modeling tools in there. Those features will be the subject of future webinars, so we'll keep you posted on those. So for the professional edition, I should as well mention we are working with a commercial reseller, a company in the UK called LQM, Land Quality Management, who will be able to sell you licenses. But as I say, today we're just showing the features of the free-to-use version as a starting point. So let's get started. I've fired up Groundhog and I've made it for me so as if it was a brand new installation. So this is what you'll see if you download Groundhog today, which you can do from the BGS website. You just fill out a small form and you get the download straight away. And when you first install and then fire it up, it will ask you for this, what we call a workspace or a home folder. It will only do this one time. So it's an important part of getting set up though, so I wanted to show you this in the demo. So Groundhog has a lot of configuration files. It also caches things like map tiles, as we'll see as we go through the demo. So it needs a little place to store information. And also things like borehole log templates that you might customize and design, which we'll also see in a bit. So the folder you choose for your Groundhog home is really quite important. It should specifically not be in an area like program files, because if you have Windows security settings set to high, or if you have corporate security issues and policies, you will struggle. So you will need to pick just a general folder that you might use for general file saving. So I've made one already called My Groundhog Home. This is just an empty folder. And then I just click Save. Groundhog will then initialize some resources, so it might take a minute or so to get started. And you can see from the splash screen text here, we're coming in as Community Edition. So this is again the free-to-use version of Groundhog. So this is what Groundhog looks like. We've tried to make it as uncluttered as we possibly can. So when you come in, there's only a few tabs and a few buttons, so you don't get bombarded with user interface controls. So in this left-hand panel here is where all of your data objects are going to appear, and you'll see examples of what we can put in as we go through, but it will be things like points and shapes, boreholes, geological cross-sections. The models folder is more for the professional edition when you start to get into 3D modeling and so on, and conceptual site modeling. And then we have some system objects where things like our borehole log templates appear and any web map services and things like that. In this tab, we also have a list of what we call drawing codes or rock codes. When you first install Groundhog, you get this really basic set of lithological codes with colors and ornaments, but you can customize that and add your own. So there are buttons here to add colors and codes. The time tab, we'll ignore that for the moment, that's a bit specialized, but there is a help panel here with links to our YouTube channel videos and to the online help. There is also under the help menu, so we have this main menu here with lots of options, and under help here we have the user manual as a PDF as well. Okay, so let's get started with some actual interactive work. And I'm going to start by opening a map panel. So I'll click this button here, and straight away it will present me with a series of options for adding layers to that map. I don't have to select any, but to begin with, I'm just going to switch on a kind of grid, which we call a graticule, and apply. And then I'm just going to maximize this, arrange this window a bit so we can see what we're doing. This is just a blank map, the idea being that you load your own data and display it in the map, but there are a few preloaded options. If you need to add another layer, we just click on this button here and we open this layer panel back up again at any time. Groundhog is pre-configured with a few layers for the UK because obviously we are coming out of the British Geological Survey. At the moment we have a topographic base map linked in the configuration for the UK, but we are looking in a future version to be able to switch on perhaps an OpenStreetMap layer, but we're not quite there yet. So I'll show you in a minute how you can get your own base maps in if you're not working from out of the UK. You can still do it. So the map window in Groundhog is just navigable like Google Maps or a GIS. Just click and drag to pan the map around. The mouse wheel scrolls in and out. And then everything in the map window is a layer. So you can see in this panel on the left-hand side, we have each thing in the map is a separate layer. And we can change the opacity or transparency, however you want to say it, on each of these layers. And you can also reorder the layers from front to back. Okay, Groundhog, the map window and the whole data model is really basically just a grid-based like Cartesian data model. So it has no real concept of coordinate systems. So it expects your data to have been projected into a local grid system before you start to load it. So it can't handle that long, but as long as you've got an X and Y in your local grid, it will display it. So let's get started adding some data. So I've got some really basic example data to work from here. I've got a folder of stuff. And I'm going to start with borehole data. Now, the way I'm going to do this, just to save a little bit of time, is I'm going to drag in what we call an AGS file. So AGS is a UK sort of trade body around geoenvironmental and geotechnical data, but it's basically just a comma-separated borehole file. Some of you on the webinar now might be familiar with AGS, some of you not. But we'll just get started with this because I just have an example file here that has some nice data in we can play around with. So as you can see there, I can just drag the file in. And now I've got this folder of boreholes here, 44 locations in this. But you can also go via the import menu. And there are various options here for importing boreholes from, for example, CSV files, and I'll show how those are mapped in a moment. And I think formats like AGS. You can also bring in things like images, which we'll see later, Esri, ASCII grids and shape files and so on, and geophysical wireline logs, which we'll also see in a moment. So this borehole data then appears in the tree, and each borehole has its own entry, possibly with a geology log attached to it, so you can see these are intervals from and to, top and base, with a series of attributes attached. We can have metadata attached to the borehole level as well, and we can have geometry. So this is X, Y, and ground level. We are also working towards support for deviated boreholes, but we're not quite there yet, I should stress. You can then attach any number of arbitrary tabular data sources to your borehole dataset. So each borehole folder has this data tables subfolder, And you can see in this example, this is why I've loaded it, because it's got loads of interesting stuff in here. This is really just to show you the scope of what could be loaded into Groundhog. I'm not going to go through all of these in detail, but in this example, it's geotechnical information, but it could be any kind of data. It could be geochemical, geophysical. So let's have a look into one of these so I can have a quick view of one of these tables. And if you bring in tabular data, so you can do this, for example, from a CSV file or a tab separated text file, it pulls up the list of all the fields within your data file, and then you can map them to fields that Groundhog understands, such as IDs, X, Y, depths, and so on. So it knows how to handle that information. And then the data we can see here. So this example here is some kind of penetration testing. So you can see that it supports as many data result fields as you like. So what I'm going to do is to add that layer now to the map. So if I click the Add Layer button in the map window, you can now see that this file that I just dragged in is available as a layer. So if I click Apply, you can see up here, actually the data's up near Edinburgh in Scotland, and I can zoom to that quickly. I can scroll in with the mouse scroll wheel, or I can use these plus and minus buttons to zoom in and out. But if I make the layer active, so I click on the layer, it becomes orange, then I can use this zoom to tool to jump into the specific location. If Groundhog's newly installed, that might take a moment because it caches maps from the internet tile server as it jumps in between different locations. So let's just ramp up the opacity on those. So now we can see these borehole locations. I'll fade the topo map out a little bit. So you can see actually we've got different symbology here for boreholes versus trial pits in this particular example. And I'm just going to choose a global log template. I'll explain what those are in a second. If I hold the Shift key, I can sort of get a preview into each of these locations. So you can see little logs appearing. So we're going to explore the borehole log capability in a moment, but I just want to get my map arranged with a little bit more data to begin with. And if you remember at the start, I explained that this topographic base map that we have is only available for the UK at the moment within Groundhog. It's a third-party web service as well. So generally, you might want to think more about bringing your own data layers in. I've got an example here that I've clipped out of OpenStreetMap for this area. I did this using QGIS, so you can use QGIS or QGIS, however you want to pronounce it. You can just export a map with a geo-registered information, so Groundhog supports world files. You could do the same from Esri's ARC product as well, or any GIS. So I'm just going to drag that into the session. It doesn't immediately appear in the map because Groundhog isn't sure what you want to do with that image. But it will appear under this folder here in the tree. You can double click just to view it. But then if it has geo-registered information, it will say that in the label here. That means you can add it to the map. So again, I add a layer, click on the entry for the image, click apply, zoom out a little bit. So if I switch off that original web service topo map, you can see I now have my OSM tile loaded and geo-registered. New layers appear automatically on the top, so it's now obscuring everything. So I'm just going to drag that down to the bottom. So other things, obviously, that you can add using that functionality is aerial imagery. So I've got an example here that I'll drag in. And let's just add that into here. So you get the idea that you can basically overlay as much information as you like in here. Another little neat feature just to show you is we have the concept of what we call a slider layer. So if I want this 100% opaque, but I want to see what's underneath it, I've got a little toggle button here on each layer, and then I can switch on what we call the slider tool that allows me to quickly compare two different layers. So that's worth knowing about. The other thing you get, again, if you're working out of the UK, is preload all of the BGS Open Geoscience web map services. So if I go to add a layer, in this panel on the right, you can see loads of stuff from the BGS coming in. In theory, if you have a WMS service available for your own geographic location, that should load into Groundhog. Although your mileage might vary a bit there because some WMSs are a little bit quirky, but that's functionality we are working on. So if you need help with that, just get in touch with us. We'll show you how to get in touch with us at the end of the webinar. So I'm going to switch on this 1 to 50,000 BGS superficial deposits map, and you can see that comes in as another layer. Sometimes active layers are queryable, so if I activate this layer and just click somewhere in the map, I get this identify, a bit like in a GIS, and that works for some of the BGS layers, for example, so that's quite useful. In terms of BGS data, we also have, for example, the BGS borehole records layer. So BGS has an archive of probably tens, if not hundreds of thousands of borehole records across the UK, and they're available to query from within Groundhog as well. Again, I appreciate this is a BGS specific function, but it's worth mentioning just quickly that these points are then queryable. So I can click on a location, I get my identify result, but in the case of borehole records, I also get to click this button here, which will link me out to the scanned record on the BGS website. So that's quite useful. So let's clear down a bit of this and have a look at digitising tools. So within the map, you can draw your own stuff. So I can right click anywhere in this white space here, and I can add point layers, borehole layers, and shape layers. So if I have a point layer, give it a name. Note that that appears also in the data tree. And then I can make that layer active. Layers that are editable or that you can digitize into, when they become active, you get this drawing tools palette. This will look different depending which layer you're working on. In the case of points, obviously you get a point tool, and I can just click to position points. I can also then attribute those points. So I can do sort of name value pairs on those. I can add as many attributes as I like manually. And then I can set things like size and color for those points graphically. I can also do shape layers. By shapes, we mean lines and polygons. Within Groundhog, we group those together into one layer. We'll ignore these rectangle and ellipse for a moment. They're a little bit specialized, but we have this Polyline tool where we can just single click to place nodes and double click to finish. We have what we call a pen tool where we can sort of click and hold, and then we can just drag to draw a line. So that's quite good for sort of sinuous shapes or curved shapes. And then we have a polygon tool, which is the same as the Polyline tool, but it just closes off the line into a polygon. I'll just kill that drawing palette to deactivate the layer. And again, you can then set the color. If the objects, either the points or lines, are attributed, say if it was a structure contour, it would be attributed with a Z value or something, or elevation. You can switch on labels. I don't have anything at the moment, but just to make you aware that's there. And then you can change thickness and color and so on. These layers then from the data tree, there's various tools on them, so you can do things like simplify and so on. But you can also export to a shapefile as well. You can also import from shapefile into Groundhog. So there's a bit of interoperability there with a GIS system. So next I want to start having a look at borehole logs. So we've got a fairly sophisticated borehole log template capability in Groundhog. So we'll have a little walk through that. So any borehole location in the map, you can right click and select view borehole log. You can do the same from the object or data tree as well. So often you'll find the same function available both in the tree and in the map, just for convenience. So let's go view borehole log. When I do that, it will ask me which template I want to use. So we have the idea of custom log templates. I've got this AGS 4 example template. These are the default templates that ship with Groundhog. The AGS 3 and 4 are obviously specific to the UK AGS data format, but then we have also these other basic examples and a gamma log example, which I'll show briefly in a second. So let's go for AGS 4. So this gives you some idea of the kind of thing you can achieve within Groundhog. These default templates are always fixed, so you can't break them, so you can't edit these, but we'll have a go at editing one in a moment. So you can see we can do things like scales, installation logs, description, samples, so on. Before I move on to editing custom templates, I just want to bring in a geophysical Y-line log from a LAS file format. So this is one example actually that I took from an open data layer from the Kansas Geological Survey. This is all the data, so we've got fields like gamma and so on. And we can view that just as a quick demonstration with this gamma log template. So you can do things like curve data as well. Okay. So I just want to show you very quickly how you would generate your own templates. So the idea is if you've got specialist borehole log data, you make your own custom log template. So I can make a new template. I get to choose whether that belongs to the project or to the whole workspace. So if I add it to the workspace, it's available across all Groundhog sessions. Give it a name. And then that's available in the system. So if I go back to one of these borehole logs here from my AGS file and view the log, I can then choose this new template as an option. And it comes up blank, but I can then start to edit it. So if I go into edit mode, I can move all of these guidelines around to arrange it how I like. I can use page setup options to set the paper size, for example. I can set things like the font size, and so on. I've got functions like fit to page to make sure it fits A4, for example, if that's what I'm working to. I can flip the aspect of the page. Just in case people are watching on smaller screens, I'm actually going to step that up to an A3 size. So let's go ahead and start adding some stuff to this template, just to give you an idea of what's possible. Again, this is just a brief demo, so there's loads more detail in the user guide if you want to refer to that later. We will aim to do a full webinar actually on borehole log template editing at some point in the next few weeks because it's quite a complex area. But I can edit things like the these header fields. So I could type in free text and then I can insert preset fields. So I've got things like page number, date and time that I can stamp in. In this case, I'm going to pick location ID from the borehole level. And then that will be dynamic. So whichever borehole I add to this particular template, it will dynamically add the location ID. Then I can edit these fields as well. So for example, I can look up to any of my tables. So you saw in the example of that data set that I have lots of data tables attached to this particular data set. So I can drill into any of those tables. So in this case, I know there's a table called Proj, which is the project table. And from there, I can pick any field. So I'm going to put the project name in and apply. So you can see that then comes in dynamically. Incidentally, this particular example of AGS data is one that I downloaded from the BGS website because we archive a lot of industry data in that format that's available for people to download. I'm just using it as an example. So this area here now highlighted orange is my column header. So I come in by default with one blank column with the expectation that I add my own custom columns. So if I right click, I can insert on the left or the right, new column. And then I've got various column types available. So borehole installation, curve, which is what we saw with the gamma log, a depth scale, a geology log, etc., etc. So let's start with the geology log here. And then all I need to do is to go ahead and map that to whichever table and field contains my geology data. So I know from this file that it's in the geol field. Obviously, it will vary depending on what your data looks like. And then I have this field called geol-leg, which is geolegend in AGS terms. And then it will draw the interval log. At that point, I can delete this default blank column. And I'm also going to insert a scale column. So I've got a depth scale type, and I can then arrange these as I like. And finally, let me just do one for text. Let's pull in the geology description, which I know is in this particular table and field. That's just a quick view of this. Each column type has various settings which look different for different column types. So I can do things like switch ornaments on and off, switch on labels and so on. So I can have that appear in different ways. If I have colors available in my coding library here for the actual values, then they will actually appear colored up. So if I add a color for the ledge code 224, let's make that pale blue, then all of those will appear blue. So you can develop your own color schemes. Okay, so the next thing I would like to do is to switch away from boreholes and go into drawing cross sections, which is another major feature of Groundhog. So I'm going to just clear up my map interface a little bit. So all of the cross sections are digitized into the map first, and you draw into the cross section layer. So if you go ahead and add the cross section layer, which is always there as a layer in Groundhog, it's basically just like a shape layer, but a special version of a shape layer. When you first add it, nothing appears to happen because we don't have any cross sections yet. So if I make this layer editable, I can pick up, we only have one tool for cross sections, which is Polyline. Now, because it's in cross-section drawing mode, whenever I hover over a borehole location, it will treat that as a special situation. So I can actually draw the cross-section snapped to those boreholes. So as long as I'm hovering over it and it shows the tooltip, I know that it's going to pick that borehole up if I click that location. But I can just click anywhere, and you don't need any boreholes to draw a cross section. You can just sketch in Groundhog. So let's do a cross section kind of southwest to northeast like that, give it a name, and deactivate the cross-section layer. The cross-sections appear in the tree on the left, and you can view them from there, view cross-section with a right-click, or you can do it from the map as well. So I've done that and nothing appears to have happened. That's because I've maximized the map window. So if I just drag this up here, I can also use these buttons here to minimize and maximize. Then you'll see in the lower portion of the Groundhog screen, we have the cross-section appear as a slice or profile view. Groundhog community by default ships with a UK, it's an Ordnance Survey Open DTM, but resampled at 250 meter resolution to make it a reasonable size for the download. So it will always give you a terrain profile of sorts in the UK, but you can load in, and under this models tab here, reference grids, if you load in an Esri ASCII grid, that will be available. So if you have a local DTM or DEM, you can load and you can set that here as the profile for the section. So you can see here my boreholes have come in. Obviously there's a bit of difference between the ground level and the terrain profile here. That's probably because we've got a really coarse DTM, and or the ground level might have changed because obviously this is an active civil engineering site around this intersection, road intersection. So whichever template you have set against the boreholes, or whichever default template you have globally, it will use that. But you can have different templates for different boreholes, even within one section. So you could have a few geophysical logs and a few geology logs all mixed together with their own custom templates. This is arguably a bit of a complex template for using in a cross section, but just for demo purposes, it gives you the idea. You might just want a simple stick with labels for correlating. And you'll notice that within the map, when I move the mouse cursor in cross section, it will show me within the map where I am in terms of position. So that can be useful if you're correlating up against geological map data, for example, as well. So one thing we might want to do is, it can be quite fiddly and not desirable to put the cross section through every single borehole. So we might want to potentially buffer in nearby boreholes, and there's a tool to do that as well. So these ones on the left, if you remember, we actually added those explicitly to the section. But over at this end of the section, we've got a few nearby boreholes that we might want. So again, everything in the cross section is layers, and we have a borehole layer. And if we go to the settings for that layer, we have a projection or buffer distance option. So let's say 20 meters. Everything in Groundhog is always meters, although if you bring data in feet, you can display it because it will do a conversion in the boreholes. So you can see that's actually picked up just one borehole. I think it's this BH115. If I'm not happy with that, I can just increase the distance. 650 is probably a bit too much. 50 meters, and then more boreholes will come in. You'll see they're highlighted in red here to show that they are some distance away from the section, because obviously if you buffer from quite a long distance away, especially in hilly terrain, you could end up with quite spurious ground levels. So it also gives you a label to tell you how far away that particular borehole is. Okay, so obviously in a real project, you will use all your borehole information to correlate your cross-section. For the purposes of simplicity, I'm just going to do a sketch today. So I'm going to switch the boreholes off. And I'm going to use this opportunity to show you another feature, which is the ability to bring images into your cross-section. So let's say I have this beautiful geological cross-section that I've sketched. I can bring that into Groundhog and register it into the section to draw over. So I'll just drag that in, Again, you can also bring images in through the import menu as well. And I'm just going to maximize the section window. And I'm going to add a grid or graticule to give me an approximate scale to work to. There's also a vertical exaggeration setting here, so I'll scale that back a bit. So my vertical scale is now 5. And then I can just go ahead and add layer, and I should see I've got all my images in here. So I've got that aerial map, I've got the OpenStreetMap. Clearly that makes no sense in a cross section. Groundhog doesn't know that. It just shows you all possible images. I've also got this section sketch. So if I click apply, it will bring that in. And if I make the image layer editable, I can then drag that, move that, stretch that to be in the correct location. So I'm not going to labor this too much. I'll just do it approximately, but it just gives you an idea. So let's then fade that out a little bit. So if you're just doing cross-section sketching, you can draw your own terrain profiles, by the way. So if I make the terrain active, I can place nodes, so I can just click on the line to make it active, then just drag the nodes. You'll know the line's active because the nodes are green. Drag them around. I can double click to place a new node, and I can double click to delete nodes. And now I'm going to go ahead and draw some geology. So I'm going to do a very fictional drawing here. So you can see the rock codes in my conceptual sketch are till, alluvium, river terrace, and bedrock. I'm not actually going to honor those. I'm just going to show you the drawing tools using arbitrary drawing codes. Everything we draw into the geology layer here, if I switch that on, it will give you these 2 digitizing modes, like in the map, Polyline and pen. And then all I need to do is pick a rock code from the library. So I'm going to actually draw till as made ground just because the color matches. I can also pick a drawing code from this button here, which opens up a copy of that panel. So I just sketched that in approximately like that. Single click to place nodes, double click to finish. And then it just appears as a line. If I want to convert that to a colored polygon, I just click the line again to make it active, and then I can drag it up to other lines, and it will snap to those lines. So I can snap to the edge of the section like this, and I can snap to the terrain profile or topographic profile. I can then shape this line, add nodes, make it as beautiful as I want or not. So let's fill the rest of this section in. Again, I'm using quite arbitrary rock codes. Let's use the pen tool for this one. If I start slightly the other side of one line and finish slightly the other side of another line, it should snap automatically. That takes a little bit of practice. You can do it. Let's pick gravel for the river terrace. So obviously, appreciate I'm doing this quite roughly just for the purposes of demonstration. Didn't quite snap this, so let's drag it up to there. So as you can see, it has this like a polygon builder running in the background all the time. So whenever you snap something, it will try and build a polygon. If you're not happy with the location, you can drag it around, and as you can see, it honors the snap on both sides of the geology. If you snap something and you need to take it away, you use the control key, and that will allow you to unsnap. Another quick tool if you just need a flat base for your cross section. So here we've got bedrock. I'm going to put that in around elevation 0 meters. So let's pick a geology code for that. Let's go for something with a bit of a different color. So I can just, once I've got a rock code selected, I can right click and just create a line of that code type. And I can do that as fixed elevation or fixed depth, which will be relative to the layers above. So I'll just go fixed elevation, 0 meters. Click OK. And that's our geology section. There are various options graphically on this layer. So if I go to this little options button, I can switch on and off individual layers. I can switch off the ornament. I can switch off the fill, just add the ornament, for example. I can hide the snapping points, and I can sharpen up the borders, for example. So that's a really sort of super quick whistle-stop tour of the real basics of Groundhog in community mode. So maps, boreholes and cross-sections, which are our sort of bread and butter. And what I just want to show you finally before we go to Q&A, we've got about 15 minutes left if people are interested. I'm just going to put this into our 3D window. So our 3D window is a relatively new addition to Groundhog. We're very, very proud of it. It's really kind of brings things to life for us. So up here, there's a 3D window button. And what I'm going to do is just add some of the data we've loaded into this scene. So the 3D panel opens as a separate application window within Groundhog. And then under this layer control, we have the similar or familiar add layers buttons. So I can add my borehole layer, for example. By default, these appear just as sticks because, again, you need to tell Groundhog which field to display. So let's go into the settings. And in this case, I'm going for this John Ledge field. And then I can change the thickness of the cylinders and things like that. Let's put some vertical scale on there. In 3D, unless it can find colours, it will just apply random colours to each geological layer or object. And then let's just finally throw our cross-section layer into there. So you can see actually it also includes the registered image in cross-sections. If we don't want that, I can expand the object control, and then I can switch on my individual geology layers, but also I can switch on and off the image as well. So you get to have a sort of 3D view of your data, and you can change things like can fade things in and out with transparency and so on. So once you're happy with that, just a quick note to where the save button is. If I click save, obviously it's always important to save your project as you go along. And Groundhog will save everything for you, all of the data in the data model and all the layout information. So any maps, boreholes and sections you had open in your previous session, when you load it, they will reappear. So I think I will stop sharing at this point, and we'll go to thank you to everybody for your time. It's been great to have so many people from so many different walks of life, students, academics, it looks like on the system, small companies, large companies, and people from all around the world. It's been really nice to see that. We're all on social media, so please, if you're interested to keep up to date with what we're doing, we're posting on there every day or two about new developments, mostly on LinkedIn, a little bit on Twitter. Go to the YouTube channel and subscribe because we're adding videos a bit more proactively now onto there. So just Google that. We'll probably follow this webinar up with an email with all of those links and how to get hold of Groundhog, and a reminder of how to get in touch with us by email. So please feel free to do that at any time. So yeah, thank you very much to everyone for your time and for your questions.